Again, on your calculator, you have a square root key. We could take the square root of 8 if we wanted to in our calculator, couldn't we? And what would we get if we took the square root of 8?
2.8284.
So it's approximately 2.8284. Well, what's that next digit? 2. So we're okay. We need to round it. We could do this and come up with the decimal answer all day. Today we are simplifying radical expressions. You're going to have problems like radical 8 or square root of 8. And we're going to simplify. I'm not looking for the decimal answer. I'm looking for the radical form. Does anybody have their own calculator? You do? Can I see it, please? You're okay. You're fine. I just need to see which one they are. There's one that you can't use. You're fine. You must have your own. There's some calculators that will do this for you, and I don't want you to use those, so I'm just going to do it by hand. Okay, so that's all I was looking for. I think you guys are fine. Those of you that show me your calculator. Okay, so what I'm looking for today is I'm looking for your answer to be 2 radical 2. That's going to be your simplified radical answer. And I'll explain to you how we're going to come up with this. Now, in order to simplify these radicals, we have to know our perfect squares. We have to be good at identifying that, oh, I know that number right there, that's a perfect square. Or that one, no, that's a prime number. I know it can't be factored any further. So to help us get started, we're going to make a list of perfect squares. And I would list these into your notebook because it will be helpful to reference this as you're going through and simplifying these radicals. So let's just start. 1 squared is 1. So we would say the number 1 is a perfect square. 2 squared is 4. So we would say the number 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. 5 squared, 25. 6 squared,
36.
7 squared,
49.
8 squared,
64.
9 squared,
81.
10 squared,
100.
11 squared,
121.
121. 12 squared,
144.
13 squared. You'll have a calculator, right?
169.
Correct. 169. How about 14 squared?
196.
196. 15 squared?
225.
225. 16 squared?
256.
256. And we can keep going. I mean, there's like an endless list here. But this is a good start. This will help us to identify some, not all, of the perfect squares that we're going to encounter. If you see any of these numbers, it should automatically turn a light bulb on your head and think, oh yeah, that's a perfect square. I remember that when it was on my list. I want you to be familiar with this. You guys know what perfect squares are. We know that if we take the square root of them, it's going to give us a perfect number. Correct? Like the square root of 16 is?
256.
Wait, square root
Oh.
of 16
My bad.
is 4. You go the other way. Square root of 25 is 5. I want you to recognize these things because you will need to know those to help you simplify today. So that brings me to my next step. Not this one. Here's our first example that I'm going to show you how to simplify. So into your notebooks, please write square root of 50. You might hear me say the word radical every once in a while. We call this square root of 50, but it can also be referred to as radical 50. That's what I'm saying, radical, okay? Not like this is a radical idea, a cool idea, you know. That's not what I mean. Radical is just another name given for a square root. And oftentimes when you get past the basics of taking the square root and calculator, we call them radicals. Okay, so it's the same thing. I mean, the same thing. All right, so simplify radical 50. In order to simplify these numbers, I need to know if 50 has a factor That's a perfect square. Now think about what I mean by factor. Factor is a number that goes into 50, a number that I can multiply by something. That's a perfect square. Look at your list of numbers. There is one on that list that goes into 50. What is it, Laura?
25.
25. Do you agree that 25 times 2 gives us 50? Okay. So this is what we're going to write this as. Square root of 25 times the square root of 2. Because 25 times 2 gives us 50, correct? Same value. Now the reason I chose 25 is because it's a perfect square. Because I know the square root of 25. What is the square root of 25? 5. So I'm simplifying this radical right here and saying, okay, I know the square root of 25 is 5. What about radical 2? Do any of the numbers on your list go into 2? 1, but 1 we really don't worry about. It doesn't count necessarily. Any others that go into 2? I don't believe so. So we would say that this is our simplified answer. 5, radical 2.
Okay, I'm lost.
Where did I get these two numbers? Why did I pick these two? Okay, but why 25? Why didn't I pick 10 and 5? Because 10 and 5 go into 50, right?
Greatest common factor.
It's not a perfect square. I picked 25 because it was the perfect square, correct? You guys know that 5 times 10 gives you 50, correct? But 5 is not a perfect square, and neither is 10, so is that going to help me to simplify? No, I wanted one of my factors here to be a perfect square so that I could simplify. That's why I chose 25 and 2. Okay. Let's look at some more examples. This next one we have radical 48. Okay, so we want to simplify. We don't want to type in our calculator and get a decimal answer. That's not what we're looking for. We want to leave it in simplest radical form. So look at the numbers on your list. Do any of those numbers go into 48? 16. I'm going to say 4. 4 does. And let me hold your thought for a second. You're right, 16 does as well. This is what I'll see a lot of. People will say 4 times what gives me 48? 4 times
12.
12. Do you agree that 4 times 12 is 48? Okay. Why did we pick 4?
It's a perfect square.
It's a perfect square. Now, we picked it because we could take the square root of 4. What is the square root of 4?
2.
2. Radical 12. Now, can radical 12 be simplified? Is there a number from our list that goes into 12? Yes. Look at your list. What number goes in? Doesn't 4 go into 12?
Yeah.
Okay. So let's break 12 down. I'm just going to bring the 2 down. 12 we know is 4 times 3. And I picked 4 because it's a perfect square, correct? What is the square root of 4? 2. So I had a 2 already. Square root of 4 is 2, so I have another 2. Radical 3. 2 times 2 is 4. Radical 3. Now, if you would take it this way, it'll get you to the answer. If you would take it Emily's way, it will get you to the answer much faster. Emily, do you remember what you told me a second ago? Instead of using 4 and 12,
16.
and 16 and 3. Emily says, well, instead of using 4 and 12, why not use radical 16 and radical 3? Does 16 times 3 give us 48? Is 16 a perfect square? Okay. What is the square root of 16? 4. Radical 3. That's the same thing we got down there, isn't it? The same answer. Now, why was this one so much faster than this one?
Because you had to simplify something.
We had to simplify a lot, didn't we? We have 2 perfect squares to go into 48. 4 does, and so does 16. Why pick 16?
You have to do less simplifying.
We have to do less simplifying. If you pick the largest factor that's a perfect square, it's going to be easier to get to your answer. Now, if you have trouble figuring out which one it is and you start with the smaller one, that's okay. You just need to make sure that your radical, what's left under the radical, is completely simplified. Like here I had to keep going with the 12, didn't I? So just stop. I don't care which way you do it. Some people like to start small and then break it down. Some people like to keep looking until they find the largest factor. It's a perfect square. I really don't care which way you do it. You're going to come up with the same answer. Less chance of a mistake if you do it on the right side as the left. Let's look at some more. Radical 52. Looking at your list of numbers. What perfect square goes in 52? Huh?
Just guessed.
2 is not a perfect square. Does 4 go into 52? 4 times
13.
23.
9 and 6.
No, 9 times 6 is 54. 4 and 13, I believe, are the correct factors here. What is the square root of 4? 2. Radical 13. Do any of the numbers on our list go into 13? No. Do you remember back in elementary when you talked about prime numbers?
Yeah.
They were numbers that didn't have any factors other than 1 in itself, right? 13 is one of those, isn't it?
Yeah.
There's nothing that goes into 13 other than 1 and 13, so we consider it prime. So in other words, I know I can't go any further. Now, if that had been 16 there, we know we would have been able to simplify, right? Or even 18 would have been able to simplify. Kind of look for those patterns. 13 is a prime number, so it's not anything we can simplify. Your answer. How about this one? 245.
Five goes into.
Is 5 a perfect square though?
No.
49.
49, okay, 49 times.
5.
Okay, and again, why did we pick 49?
Because it's a perfect square.
It's a perfect square. So simplify. Take the square root of 49, which is 7. Radical 5. Can 5 be simplified any further? No, 5 doesn't have any factors that are perfect squares. So our simplified answer would be 7, radical 5. How about this one? Radical 32.
8. 8.
Okay, 8 and 4 you could. That's fine.
Yeah, 16 and 2.
I hear 4 and 8, and I hear 16 and 2. Now, before we decide, how do we know which one's going to be the best route?
Because the bigger number will be easier to simplify.
Yes, pick your largest perfect square. Well, in our case, 16 is a larger perfect square, correct? It's bigger than 4. So I'm good with that one. You can still get there if you do radical 4 and radical 8. It's going to take a little more time. Let's try radical 16 and radical 2. What is the square root of 16? 4. Radical 2. Can 2 be simplified? Does it have any perfect square factors? It doesn't. Our simplified answer is 4. Radical 2. The next problem I would like for you to do on your own, when you've got your answer, raise your hand, I'll check it out and make sure you're correct. And then I'll give you your assignment when we're simplifying some radicals. video.